So this is lesson 1.1b, rational and irrational numbers. We are going to continue from lesson 1.1a. So let's get started. Okay, so what is our standard going to be today? Our standard is going to be 8n(s)(1). Know that numbers that are not rational are called irrational. Understand informally that every number has a decimal expansion. For rational numbers, show that the decimal expansion repeats eventually, and convert a decimal expansion which repeats eventually into a rational, and I believe that is number. So said in common everyday language, I can express rational numbers as decimals, and I can express decimals as rational numbers. So let's go on from there. A little bit more definitions. So we had mentioned an integer in lesson 1.1a. What exactly is an integer? Well, it is a positive whole number, or it is a negative whole number. Integers are the numbers on the number line, but not the in-between numbers on the number line. So like 1.5 is not an integer. 1 3/4 is not an integer. 10.2475 is not an integer. They are whole numbers. So here's an example of a number line. So integers could be positive or negative, but they are the whole numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Counting numbers going to the right and counting numbers going negative to the left. -1, -2, -3, -4, -5, -6, etc., etc., etc. 3.5, which might be about what this is here where the arrow is showing, that is not an integer. Okay, it is your turn to talk about what an integer is and what an integer is not. I'll see you in a moment. Okay, a few more definitions. Hopefully you got integers correct. What does rational mean? Let's think about a person that is rational. What is a rational person? Well, rational means based on reasoning and logic. So if you're a rational scientist, you use logic and reasoning to figure out your hypothesis and your conclusions. Here's an example. If you're a rational person, you make sense and you think through things. There's a rational guy right there. Rational cool guy, excuse me. Okay, what about a rational number? Now that we know what rational means, what do you think a rational number is? Exactly. A rational number is any number that can be written as a fraction in the form a over b, where a is the top number, the numerator. That's what the top number of a fraction is called. And b is the bottom number, the denominator. A rational number, keep this in mind, makes sense. It's logical. So a rational number is one that can be written as a fraction and it makes sense. The denominator cannot be 0, b. So the bottom number of a fraction can never be 0 because that is an undefined value. So that's why we say b cannot be 0. However, the numerator may be 0. That's fine. And the numerator and the denominator must be integers. That means they must be whole numbers, right? And it is okay, like I said, for the numerator to be 0. So a can be 0, b cannot be 0. Keep that in mind. So here are some examples of rational numbers. So 3/4. Is that a fraction? Yes, that's rational. How about 6 over 1? Yes, that's a fraction. That's also can be called 6, right? Because any number over 1 is just the number. But that is also a rational number. Square root of 4, is that a rational number? Well, what is the answer to square root of 4? Square root of 4 is equal to, we did this in the last lesson, exactly 2, because 2 times itself, 2 equals 4. So is 2 a rational number? Yes, 2 can be written as 2 over 1. So yes, square root of 4 is a rational number. How about 1,246 over 1,001? Is that a rational number? Well, of course, because it can be written, it is a fraction, right? Just because the numbers are big doesn't mean it's not a fraction. So yes, it's a rational number. And they're both integers, did you notice? Those are both numbers on the number line. They're not numbers between the numbers on the number line. Negative 1/3, is that a rational number? Of course. That can be written as a fraction. How about square root of 25? What does the square root of 25 equal? 5, right? Principal square root equals 5, right? So yes, 5 is a rational number. Okay, let's clear our drawings here. What about the word irrational? What does it mean if somebody is irrational? They're not using logic or reason, right? If you are being irrational, you are not making sense. You're not using logic to make your decision. So if you were hiking in the woods and you saw a great big bear, you might scream and yell and run really fast and run right into the water because you weren't thinking rationally. You were thinking irrationally because you were just thinking about the bear and you weren't taking the time to think through your decisions correctly, right? So here's an irrational guy. He's a little bit freaked out. He's not going to make good sense. So now put that in place and think, what is an irrational number? It is a number that cannot be written as a fraction in the form of A over B, where A is an integer and B is an integer, but B cannot be equal to, correct, 0. These numbers are not rational numbers. Let's take a look at some. Pi is not a rational number because it is a never repeating, never ending number. It's 3.14. Let me look at my calculator here. It's 22/7 divided by, let's see, 22 divided by 7. It's 3.142857, etc. It is irrational. How about square root of 2? Can you think of any number that you can multiply by itself to give you the square root of 2? Let's see. How about if I did 1 times 1? What is 1 times 1? Well, that equals 2, or 1. How about 2 times 2? Well, we already know that equals 4, right? So there is no exact perfect match for the square root of 2. In fact, if you put square root of 2 in on your calculator, you would get 1.412135623731, and it never repeats and it never ends. There is not an exact number to give you 2 when you square it. So that number, square root of 2, is irrational. So any non-perfect, and move that box at the bottom there, any non-perfect square root is going to be irrational. So square root of 3, there's no number that multiplied by itself will give you exactly 3. Square root of 5 is irrational. There's no number multiplied by itself that will exactly give you 5. 19, square root of 19. So all of those numbers that are not perfect squares, when you have a square root sign with that number under it, is not a rational number. Here's another irrational number you may or may not have heard of. It's called Euler's number. It is used as a base in logarithmic and exponential functions. That's something you're going to do in more detail probably in 9th grade for algebra. So, an irrational number never repeats and never ends. Let me just clear my drawings here. And it can't be written as a fraction. A couple more definitions. Terminating decimal. That is a decimal that eventually ends. It has a finite number of decimals. Terminating, think about the Terminator. He went around ending people's lives, right? He was the big scary guy. I don't know if you ever saw that movie. Arnold Schwarzenegger, I believe. So that terminating means to end. So a terminating decimal has a distinct ending place. So you could say, for example, 3.1, 3 and 1/10. That ends. That does not go on and on and on. How about 3.14, and then what was pi? I'm going to go back in there and figure it out again. 3.14285, etc., right? That number does not end. So that is not a terminating decimal. Any terminating decimal is rational. For example, 2.5, 3.456, 11.712390, and 0.67, they all terminate. They have an ending point. What is a non-terminating decimal? That is a decimal that never ends. There's your pi. It never ends. Some non-terminating decimals are irrational if they do not repeat, like pi. It never repeats. However, if a decimal does repeat, it is rational. So here's an example of an irrational number, which we've talked about, pi, that does not repeat. And Mueller's E. It is another long number that goes on and on and on forever and ever and ever and does not repeat. Non-terminating decimals that repeat are rational because they can be written as a fraction. So for example, 1/3 can be written as a repeating decimal of 0.3333333333333, continuing on forever and ever. This number is non-terminating, right? It never ends, but it is rational. Now it is your turn to decide if the number is rational or irrational, terminating or non-terminating. Give it a try. I'll see you back in a moment. Okay, hope you got those right. Good work. Keep it up. Expressing rational numbers as decimals. Take a look at what this is about. So 1/4. How would we put that as a decimal? Well, we are going to, remember this from last year. I said this many, many times. It's probably ingrained in your mind. The top number goes on the, it's right there for you, inside of the house. I call this little box, semi-box, the house. And the bottom number always goes on the outside. Doesn't matter if the top number is smaller than the bottom number. It always, always goes on the inside of what I call the house. That's not a math term, it's just something I made up. Okay, how do I solve this problem? How do I change 1/4 into a decimal? Well, I have to use my long division skills. So I go over here and I say, how many 4s go into 1? Well, that doesn't work, right? No 4 is going to 1 because 1 is smaller than 4. However, I can put a decimal point and a 0 here because 1.0 is the same as 1. So I'm not really changing the number on the inside. I'm just adding zeros. So I'm going to put the decimal point right above where I put it on the inside of the house. I'm going to put it up there right away, so don't forget. And now I can take 4 into 10. How many 4s go into 10? Exactly 2, right? 2 times 4 is 8. Notice how I put the 2 over the 0 because I took 4 into 10, not into 1, right? Now I subtract. 10 minus 8 is 2. I still have a remainder here, don't I? So now I'm going to have to add another 0. I'm not changing the number 1 above. I'm just going 1.00000. That's the same as 1. So that's not changing. So now let's bring down our 0 right here. How many 4s go into 20? Right, 5. 4 times 5 is 20. 4 times 5 equals 20. And now I subtract. 20 minus 20 is 0. And I have no remainder. And I am done. Nothing repeats. So 1/4 is equal to 0.25. Some people like to put the 0 in front. So 0.25 is another way of writing it, and that's just fine. I always kind of leave that 0 point part off just because when you multiply decimals, it gets a little confusing. So that's how you express a rational number as a decimal. And if you also think 1/4, what's 1/4 of 100 cents? Well, it's a quarter. It's 25 cents, right? And that's an example of 25 cents right there. Okay. So rational numbers, terminating decimals, they're not an integer. Okay. So a rational number can be expressed as a decimal. A terminating decimal can be obviously expressed as a decimal. And now that box is in my way again. And not an integer. Let's go on from there. Clear our drawings. Okay, 5/11. How do I express 5/11 as a rational number? Again, top number on the, exactly, inside. So even though 5 is smaller than 11, I put the 5 on the inside. And just to bring up our long division skills, there's a little acronym you can use. I think I taught this to the class last year that were 6th graders when you guys were 7th graders. It's does McDonald's serve burgers? So the D stands for divide. I'm just going to show you this little trick here. The M for McDonald's stands for multiply. The S in serve stands for subtract. And B in burger stands for bring down. Try to line that up a little bit better here. So if that is helpful to you when you're dividing, you can use that. So let's try, does McDonald's serve burgers? 11 will not go into 5. So our first thing is to divide. We can't divide yet because we have too small of a number. We're going to put a decimal point and a 0. Don't forget right away to put your decimal point in the same spot on the top of the house. So let's divide 11 into 50. Well, that's going to be 4 times, right? Because if you go 5 times, then you get 55, and that's over. You can't go over. You got to get as close as you can to 50 without going over. So I divided 11 into 50. Now I'm going to multiply 11 times 4. 11 times 4 is 44. That's the McDonald's part. Now I'm going to do the subtracting part, or the serve. Does McDonald's serve? So now I subtract 50 minus 44. 5 becomes a 4. 0 becomes a 10. 10 minus 4 is 6. And then B for burgers is bring down. Well, what can I bring down? I have to bring down another 0. So I have to put one in there. And now I'm going to bring it down. And by the way, putting these little arrows here is a good idea. Keep track of where you are in your long division. How many 11s go into 60? Well, 5, right? 11 times 5 is 55. Now I multiply. Now I'm subtracting. 60 minus 55. 10 minus 5 is 5. I'm going to bring down another 0. How many 11s go into 50? 4, right? 44. 11 times 4 is 44. The multiply part, the serve part, the subtract part. 50 minus 44. 5 becomes 4. 10 minus 4 is 6. Notice what's happening here. I'm going to bring down another 0. 60. How many 11s go into 60? 5, right? That makes 55. I'm going to run out of room on my screen, but that's okay because you can see the pattern that has developed. 60 minus 5 is going to be 5 again, right? And then I'll be back to 50 again. Notice what's happened. The 4, 5, 4, 5, 4, 5 up here. Change that to blue if I can, is going to repeat. So when we repeat numbers, we write a bar over the number part that repeats. So I would write a bar over the 0.45 part because the 0.45 is the part that repeats. So what that means is the answer is 0.4545454545 forever and ever and ever. So 5/11 equals, and I'll type that, 0.45 with bar over the 45, or sometimes you can see it written like this, meaning that 0.45 goes on forever and ever and ever. Still a rational number. Why? Because it can be written as a fraction and because it repeats. It has a pattern. A rational number. It's a non-terminating. I'm going to clear most of my drawings here. Let's just clear this away from the whole thing. I'll just clear the whole thing and just write 0.45 with line over the 45 here. Here we go. Okay, so 5/11 is a rational number. It can be written as a fraction. It's a non-terminating decimal, right? Goes on forever and ever. And it is not an integer. Why is it not an integer? Well, it's not a whole number on the number line. It's between whole numbers on the number line. Okay? Go on from there. Expressing rational numbers as decimals. We're going to continue on. 15/5. Top number on the, you got it, inside. Okay, so let's do this one. Just want to double check. Okay. We're going to put the top number, 15, on the inside. This time it is bigger than the bottom number, isn't it? The numerator is bigger than the denominator, and that is okay. How many 5s go into 15? Exactly 3. 3 times 5 is 15. 15 minus 15 is 0. So 15/5 is the same as 3. Right? Let's classify this. 15/5 is a rational number. It can be written as a fraction. It is a terminating decimal. It's 3.0, right? Or just 3. It is also an integer because it is one of the counting numbers on the number line. Clear my drawings. Try another one. 3 2/5. Top number on the inside. Yay! How do we do 3 2/5? Well, we already know the 3 is going to be there, so we're just going to divide the 2/5. So 2 on the inside, 5 on the outside. Does McDonald's serve burgers? Here we go. Divide. Can't take 5 into 2, so I'm going to add a decimal point and a 0. Try to put the point up there right away. How many 5s in 20? That's our divide part. Does. Right, 4. McDonald's, multiply. 4 times 5 is 20. Serve, subtract. 20 minus 20 is 0. And finally, burgers, bring down. Do we have to add another 0 here and bring it down? No, because we have a 0 remainder. We're good. So the answer to 3 2/5, don't forget that 3, that whole number part, is going to be 3.4. Don't forget this 3 over here. That's the whole number part. That has to go in front of the decimal. So now let's classify this number. It's a rational number. Why? Because it can be written as a fraction. And just so you know, how can it be written as a fraction when there's a whole number there? Well, you could do an improper fraction, right? Whole number times the bottom, 15 plus the top, 2. Remember that? Whole number times the bottom plus the top, up. Whole number times the bottom plus the top, up, up. Whole number times the bottom plus the top, clap, clap. There we go. Okay, so this could be written as 17/5, right? So it is possible to write the whole mixed number as a fraction. What else do we know about this number? It is a terminating decimal. It ends at 0.4. So 3.4, there is nothing after that. And it is not an integer. Why not? Because it's in between 3 and 4 on the number line. So it is not an integer. It's not a counting number. It's not a whole number. It's not a negative whole number. Now it is your turn to give it a try. I'll see you back in a few minutes. How'd you do? Good job. Okay. 0.5. How are we going to express a decimal as a rational number? A decimal as a rational number. How do you say 0.5 in words? Let's type that first. Well, that's 5/10, right? Wouldn't you say that's 5/10 if you were reading that number? How do you write 5/10 as a fraction? 5/10, right? So now we're going the other way. We're taking a decimal and we're making it back into a fraction, just so you know. But what does it say on the blue on the right there? Don't forget to reduce your fraction. How do I reduce this fraction? I find a number that divides in both the top and in the bottom. So I know that I can divide the top and the bottom by exactly 5. So I divide top by 5, I divide bottom by 5, and I get 5 divided by 5 is 1, 10 divided by 5 is 2. So 0.5 or 5/10 is equal to 1/2. That's changing a decimal into a fraction. Clear my drawings. Let's try 0.825. How do you say that in words? Let's type it out in words. That's 825 thousandths with a TH. 825 thousandths, right? Okay, how do I write 825 thousandths as a fraction? I write 825 over, what's the bottom number? 1,000, right? We said it was thousands, didn't we? This is 825 thousandths. And let's not forget to, hopefully that'll pop up. Yep, don't forget to reduce. So now we have to reduce 825 over 1,000. What number will go into both 825 and 1,000? Well, sometimes you have to do it multiple times to reduce because you can't see the biggest number that will go into both the top and the bottom. Now, I happen to know what the biggest number is, but I'm going to pretend that I'm an 8th grade student and I'm looking at this number going, well, I know that 5 will divide into the top and the bottom, so I'm going to start with 5. So here I go, starting with 5. So 825 divided by 5, if you don't know that off the top of your head, you can come over here and do long division and do 825 divided by 5. I would prefer you not use your calculator yet until halfway through the year. 5 goes into 8 once. 8 minus 5 is 3. Bring down the 2. 5 into 32. 6. 5 times 6 is 30. 32 minus 30 is going to be 2. Bring down the 5. How many 5s in 25? 5 and 25. And then I would end up with a 0 remainder, which is perfect, exactly what I want. So I have 165. So 825 divided by 5 is 165. And then I can likewise do long division to do 1,000 divided by 5. If I don't know what that is, that will be 200. And now what I've got is 165 over 200, but I realized I could keep dividing. I have not reduced this as small as it goes. So I could do another 5, and I can use long division to do that. If you notice, I could have just divided by 25 right away and gotten it down a lot quicker. So let's do 165 divided by 5. We would get 33 if we did long division, which I'll let you do on your own there for sake of time. And what is 200 divided by 5? That is 40. This is as low as the fraction will go. This is as low as the fraction will go. Anyhow, 33/40. So we have a top number of 33, that's an odd number, and we have a bottom number that's even. So we know we've gone as far as we can go in this number. So 0.825 is the same as 33/40. If you were to take 33 on your calculator and divide it by 40, you would get 0.825. In fact, pause the video and go ahead and do that. Take 33 divided by 40. What do you get? Exactly. Okay, let's go on from there. Try another one, 1.4. How can that be written as a fraction? Let's begin by saying 1.4 in words is equal to 1 and, always read the decimal point as the word and. 1 and 4/10, right? Now, how would I write 1 and 4/10? Well, I'd write a whole number 1, and I'd write 4/10. And then don't forget to reduce, or that's popping up there. Don't forget to reduce your fraction. How do I reduce 4/10? Divide top and bottom by 2, right? So 1 and 2/5. So 1.4 is the same as 1 and 2/5. All right. Oh, clear my drawing. It is now your turn. Give it a try. Okay, what is your homework? I hope you did well on that practice problems. I will get feedback from all of you on how you did on those questions throughout the video. That is data that is accumulated that I will use towards your standard grade. So your homework will be doing page 12, numbers 1 through 9. Might as well come back on here. And numbers 13 through 15. And also the name that number worksheet, numbers 1 through 8. So I hope you have, and I'm trying to stop my share here. I hope you have a good day. Don't forget to reach out with any questions that you have, and we'll see you soon. Bye.